Next speaker is Véronique Van Vlasselaer. She's analytics consultant at SAS. Last year, Véronique finished her PhD at the KU Leuven, where she did research with Professor Bart Basens on fraud detection. And the title of the talk of Véronique today is Afraid, and Afraid stands for Active Fraud Investigation and Detection Using Advanced Network Analysis.
Okay. Good morning, everybody, and thank you for the nice introduction. So, my name is Véronique Van Vlasselaer. Let me check. Yes. So I'm an analytical consultant at SAS. But before, like Nele introduced me, I was working at the University of Leuven as a PhD researcher, and fortunately I succeeded last year to finish my PhD, and I wrote actually a very nice PhD booklet. Nobody read it, even not my jury members, but the good thing is that I also achieved something else, that is writing a book about fraud analytics together with my promoter Bart Basens and another colleague Wouter Verbeke. So if you're interested in more information about what I'm going to tell today, well, just talk to me after this presentation. I have the book with me. So today I will talk about active fraud investigation and detection. I'm going to make you afraid. Right? And the very important thing in afraid is the first letter, the A, because this stands for active. And active means that I'm not just going to develop fraud detection models, I'm going to use human interaction to create good fraud detection models. Why is that? Well, if I just create a fraud detection model, it will do something quite nicely. The problem is that if I can use this business logic of humans, I can actually integrate good machine learning models with good human interpretation, and I can make the best models. How does this work? Well, suppose that in the first phase, I just have my humans that are selecting observations that they think they're fraudulent. They're investigating it, and that's it. We can do better. We can make automated fraud detection algorithms that already give an ID to the investigators where to look. Because then they do not have to scan the whole data set, right? Before we output the list of suspicious observations based on our fraud detection model, maybe it's better to ask a little bit of time of these investigators to improve our model. And this is exactly what we're going to try to do. Let me give you an example. Suppose here we have all kinds of observations. The gray ones are observations that we do not know what they are doing. Are they fraudulent ones? I don't know. Are they good ones? I don't know. But I have a set of red nodes, red observations, the fraudulent observations. I also have one good observation, an observation of which I know he will not commit fraud. This is a typical setting in fraud data sets. I only have very few observations, very few fraudulent observations, very few good observations. If I make a detection model, my model gets a little bit confused. Because what can happen? Well, my model can say, this is the right split. This is the right decision boundary. Everything on the left are the good ones. Everything on the right are the bad ones. Well, actually, this can also happen. I can have another model that says, everything on the left side are the good ones, everything on the right are the bad ones. Or maybe this decision boundary. I don't know. How can I make a better model? How can I know which of these boundaries are the correct ones? Well, let's ask the investigators. So assume that we start with this decision boundary. What I do know is that observations that lie far from the boundary, there I'm quite sure that these are classified correctly. So the ones close to the boundary, There, my model is more confused. What about asking my inspectors about the true label of this observation? Is it a good one or is it a bad one? So let's ask, and my investigator says, that observation, that's really a good one. Okay, then I know my model is not correct. So I have to update my model like this, for example. Again, I can highlight the regions of which I'm quite sure. I'm really sure that these regions are either good or either bad. And such I can continue. This is what we call active learning in research. That means that I'm really going to use investigators' knowledge to create the best model. The way that I explained it today is uncertainty sampling, because I'm going to sample the node, I'm going to ask to my investigators the label of the observation of which I'm the most uncertain about. I can also do query by committee, where I do not learn only one model, one machine learning model, but I learn many models. In that case, what my models are going to do is voting. For example, the node most to the left, all my classifiers say, well, that's a good node. In that case, I'm really certain that this node will be, or this observation will be a good one. But the one in the middle, that's exactly the observation of which my classifiers are not certain whether it's a good one or not. So let's ask. So this is active learning, using human interpretation. Now, I'm a network specialist. I'm using the way that people are connected to detect fraud. Is it also useful to use human interaction in network analysis? Well, yes. Let me first introduce what we do in network analysis. In network analysis, we say that people that are connected to each other are influenced by each other. So assume this network here, I don't know what all my observations are going to do. I only know for certain that I have 3 fraudulent observations. It's exactly the same example. For example, Nele and Philippe here, they're really good friends of each other. And every week, they're going for drinks with Julie from the University of Antwerp there. And now we have to make a prediction whether Julie will be influenced by these 2 fraudsters here in the front. How will we do that? Well, we will use network inference algorithms, propagation algorithms, where we spread influence over the network. So take a very good look at this network. When I use my network inference algorithm, I will just let the fraud that Philippe and Nele have spread over the network. And every node gets a color. Yeah, it's not completely visible, but every node gets a color, every person gets a color, and the more bright red you are, the more influenced you are by fraud. That's what we call the exposure score. Now, the problem is, these propagation algorithms are very good, these influence propagation algorithms are very good, but we can do better. If we integrate human input. Let's give you a very nice example. So here we have a network, a very fraudulent network on the right and a very good network on the left. If I don't do anything, my propagation algorithm will influence all the nodes on the left side. What do I have to do? Well, I only have to ask one question to my investigators to know whether this network is indeed a fraudulent one or not. What I have to do is ask, is this boundary node a good one or a bad one? Suppose that it's a bad one, well, in that case, we just intensify the spread of fraud towards the good one. Because actually this network is not a good network, it's a bad network as well. If it is a good network, what we then have to do is just cut the complete spread of fraud to the left side. Can we cut it forever? No, of course not, because it's not because I'm not a fraudster that I'm not going to be a fraudster in the future. Now, the things that I'm talking about today, is this real? Does this work in reality? Well, I have the pleasure to introduce to you that this method is implemented at your Belgian social security, social security institution. The Belgian social security institution uses this algorithm to detect companies that intentionally do not pay their taxes. And we use human interaction, so investigators, to specify whether a certain company should be investigated or not. Does it work? Well, yes, because we get an increase in precision of 15%. Now, another question can be, do we have to ask the inspectors many questions? Well, and this is actually very nicely visualized in this graph. Only asking 10 questions to inspectors, so just asking about the label of 10 companies, whether these 10 companies are fraudulent or not, gives us a very big increase in our precision, in our hit rate. So this is it for me. If you have any questions, feedback or comment, I will be available during lunch. Thank you for your attention.